Hi folks, this video is on solving logarithmic equations. Now there's two hints to solving these equations, and they are one, remember the log rules, and number two, you need to remember that there's no solution to this equation. So starting with our log rules, product rule says that when we have a logarithm acting on something, and that's being added to the same logarithm, so this is log base 10 for both of them, to something else, we can condense that to be log of the product of our two arguments. So log of x plus log of y becomes log of x times y. Quotient rule is very similar, except this time rather than addition, we have subtraction. So log of x minus log of y. We can rewrite that, and that indicates division in our new argument. And the last thing is our power rule. So if we have some coefficient multiplying the logarithm of something, the coefficient can be written as the exponent of the argument. So we could rewrite this as log y to the power x. So these rules are going to come in really handy because often we're going to have to combine a couple of logarithms in order to do some other algebra. Hint number two really comes down to our final solutions. So if I try to solve this here, first thing I would do is I would move the base of the logarithm to the other side. So negative 8 rather, is equal to 2 to the power x. Now it doesn't matter what we let x be, we will never ever ever get a negative number. 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. We're just getting larger and larger numbers, right? So we're getting farther away from negative 8. We go 2 to the power 0, well, anything to the power 0 is 1. 2 to the power negative 1 is 1/2. 2 to the power negative 2 is 1/4. 2 to the power negative 3, that's 1/8. So we're still positive. We're never, ever going to get a negative number. So the argument can never be negative. Argument cannot be negative. Let's jump right into some examples. So let's solve log base 5 of 3x plus 1 plus log base 5 of x minus 3 is equal to 3. First thing I want to do is apply whatever log rules that are applicable. So here we have addition, so we're going to apply the product rule. So we're going to combine this into one logarithm, log base 5 of 3x plus 1. Then we end up multiplying by our other argument, x minus 3. And that's going to equal 3. Next, I'm going to write this in exponential form, so 3x plus 1 times x minus 3, so my old argument stays there. And then the base gets written as the base of the exponent. And now I kind of have a quadratic question, so back to grade 11 for us on this one. So we're going to multiply these two binomials together to get 3x squared minus 9x plus x minus 3, and 5 cubed is 125. Next, I want to bring everything to the same side. So 3x squared minus 8x minus 128, and that's equal to 0. At this point, I can either factor this to solve it, or I could use the quadratic formula. Either method is perfectly fine. I'm going to use our factoring, where we have a times c sums to b. Our value for a is 3. Our value for c is negative 128. So 3 times negative 128 is negative 384. And our value for b is a negative 8. So what I would do is I would try to find all of the factors of negative 384. So 1 and negative 384. You could also think about 2 and 192. It's also divisible by 3 and negative 128. And we could just keep listing numbers as we go down here, but I'm going to jump to 16 and negative 24. So when you add these two numbers together, that gets us our -8. So this is our magic pair. So I want to split this -8 into 16x and -24x. So 3x squared plus 16x minus 24x minus 128 equals 0. So then I'm going to put brackets around the first two terms. Then I'm going to put brackets around the last two terms. Then I'm going to remove any common factors that we have. So in our first set of brackets, we just have an x in common, which leaves us with 3x plus 16. And in the next set of brackets, we have a -8 in common, which leaves us with 3x plus 16. So there's a 3x plus 16 in both terms, so 3x plus 16 and an x minus 8. So when they multiply each other, that equals 0. So when we have two things multiplying to equal to 0, either the first thing is equal to 0 or the second factor is equal to 0. So 3x equals -16, x equals -16 over 3, or x equals 8. And these are my two solutions. But this is where our second hint comes in, where the argument cannot be negative. So we need to check both of the arguments to see if either of them are negative when we plug in the value for x that we found. So 3x plus 1 and x minus 3 are our two arguments. So here are two arguments. Let's plug in this -16 thirds first. So 3 -16 thirds plus 1. So here we're multiplying by 3 and dividing by 3, so we get -16 plus 1, so -15. So automatically, this does not work because in our one argument, we get a negative number. Now, you'll actually get a negative number here as well, but I'm not going to bother checking that one because we already saw that it doesn't work with the first one. So now let's try 8 in both of these arguments. So 3 times 8 plus 1, so that's 24 plus 1, which gives us 25. So that's a positive number, so that's okay. Now let's plug in 8 in the other one. So that equals 5, that's positive, so that works. So I have one solution, x is equal to 8. Example number 2, we're going to follow the same procedure. Step number 1, we want to combine any logarithms that we can. So these two logarithms are separated with addition, which means we can multiply their arguments. So log base 2 of x plus 6 multiplies x minus 1, and that equals 3. Again, second step is the same, move the base to the other side, so x plus 6 minus x minus 1, that stays where it is, and then we get 2 to the power 3 over here on the right. We're going to multiply our binomials to get x squared minus x plus 6x minus 1, and 2 to the power 3 is 8. Then I'm going to move everything to the same side, preferably the side where that keeps the squared term positive. So x squared plus 5x, this should be minus 6. So it ends up being minus 14 equals 0. Then I need to factor this. We can use our a times c sums to b method again, but might not need to. I need two things that multiply to x squared, which are x and x. And I need two things that multiply to -14, so one has to be positive, one has to be negative. And they have to add to 5. So if we go positive 7 minus 2, I think that does the job. So Again, we have a product equaling 0, so either the first factor is equal to 0 or the second factor is equal to 0. So x is equal to -7, or x is equal to 2. Again, we have to check our solutions with each argument to make sure that our arguments are positive. If the argument is negative, we have to cross out that solution. So x plus 6 and x minus 1 are my arguments. So let's plug in. So let's plug in the -7. -7 plus 6 is -1. So I don't even need to plug it into this other one. I know that this one does not work. And you actually have to show that you get that solution and then reject it. So you have to get it and then throw it away. Now let's check the x value of 2. So 2 plus 6 is 8, so that's okay there. And then 2 minus 1 is +1, so that works. And this is our solution. Example number 3, same process. We want to combine logarithms where possible. So they're separated with addition. That means we get to multiply their arguments. So log base 5 of 2 minus x times x plus 4 equals 1. And then I'm going to put this into exponential form. So 2 minus x times x plus 4 stays in the same spot. And then we get 5 to the power 1. Then we multiply our binomials together to get 2x plus 8 minus x squared minus 4x. And 5 to the power 1 is just 5. Now I want to move everything to the same side of the equal sign. And I want my x squared term to be positive because that's just how I prefer to factor. So that means I'm going to move everything over here to the right. So we get 0 equals x squared. -4x and 2x combined to be -2x. Then we have to move that to the other side. So we get positive 2x. And then we have to subtract this 8 to the other side. So we get -3. So I need two things that multiply to x squared. And I need two things that multiply to 3, which is only possibility is 3 and 1. And one has to be positive, one has to be negative. So if we let 3 be positive and the 1 be negative, I think we get our desired result. So now we need to solve this. Either x minus 1 is equal to 0 or x plus 3 is equal to 0. So x is either equal to 1 or -3. Our last step, we need to check our solutions to see if they work with our arguments. So our arguments in this case are 2 minus x and x plus 4. So let's check 1 first. So 2 minus 1 is 1, so that's okay. And then x is equal to -3. Just because it's negative doesn't necessarily mean that we have to throw it away. Although I guess I should check the one on the other side first. 1 plus 4 is 5, so that's cool. We know this one works for sure. Checking the negative one. 2 minus a -3. So subtracting a -3 is like adding 3, so that ends up with 5 here. And then we plug in the -3 on this side. Leaves us with +1. So it is possible to have an x value that's negative as long as the argument itself ends up being positive. Time for our last example. So I see that we have two arguments that have x's in them, and then two arguments that don't have x's. So I'm going to bring all of the logarithms with x's as arguments to the same side and move everything else to the other side for starters. So log of x minus log of x minus 2 equals log 5. Move that to the other side of subtraction, so minus log 4. Now I can combine these logarithms, this subtraction, so we're going to have x over x minus 2 as the argument of the logarithm. On the other side, oh, we have subtraction again. So log of 5 over 4. Now if I put this in exponential form, or I think that I just have one logarithm on the left and one logarithm on the right, if the bases of the logs are the same, then the arguments must be the same. So x over x minus 2 is going to equal 5 over 4. So to make this a little simpler, I'm going to multiply this denominator to the other side. So x equals 5 times x minus 2 over 4. I know there's some of you that don't like fractions, so why don't we multiply this 4 to the other side? So we have 4x. Now I'm going to multiply the 5 through the brackets to get 5x minus 10. No more fractions. Most people are happy. So we have more x's on the right than the left, so I'm going to move these 4 x's over. At the same time, I'm going to move this 10 to the other side. So 10, 5 minus 4x is just 1x, so 10 is equal to x. Once again, we need to check our arguments to make sure that they're positive. So our arguments, once again, were just x and x minus 2. So x and x minus 2. Well, hopefully you can see that 10 is positive, so that one works. And then 10 minus 2 is 8, so that one works. Our solution is 10.